Today we're going to be introduced to compound interest. This is the last new aim in our topic. The do now goes back to 7th grade when you did simple interest. It says to buy a computer, Raquel borrowed $3,000 at 9% interest for 4 years. How much money did she have to pay back? So to find simple interest, you use the formula I equals PRT. P is principal. It's in this first box here. P is principal. R is the rate, and T is the time. So the principal is so I equals interest. The principal is what she borrowed. The rate is not 9, but 0.09, and the time is 4 years. And I'll do this in the calculator. Times 0.09 times 4. So the interest that she owes is $1,080, but she doesn't pay $1,080 back. She also has to pay the principal back. So she has to pay back the $3,000 plus the $1,080, and that would be $4,080. Now, today, what we're going to be doing, compound interest, your interest compounds a certain number of times over a year. So if it's compounded annually, once a year, each year the interest would be added on before it computes the interest after that. So that made no sense. For instance, you would take the $3,000, okay, pay 9% of it the first year, and that would be, for 1 year, it would be $270. So the first year, you would owe $270 on top of the $3,000. The next year, you would have to pay interest on the $3,270. The interest gets added on to the principal before calculating the interest for the following year. So the following year, the interest would go up. And now you would owe, for the second year, $294.30. And then that would get added on to the $3,270. So that's how compound interest works, as opposed to simple interest, where you pay the same amount of interest each year. And the compound interest, the amount of interest goes up each year because the principal goes up. It went up from $3,000 to $3,270. That $3,270, I would have to add the $294.3 that we got. So then for the following year, your principal would be $3,564.3, and you would multiply that by the 0.09 again. So that's compound interest versus simple interest. So the simple interest, we just discussed the formula for. Compound interest, here's the formula right here. Okay, you take the principal, you add, so to get the new amount, that's the A, you take the principal, the amount you start with, and you times it by 1 plus R over N. R is the rate as a decimal, like we've been doing. N is the number of compounds per year. And then T is the number of years. So let's talk about that N. That's what this box here talks about more. The number of compounds in a year. So if it says that the interest is compounded monthly, then that means each month the interest gets added on, and you would do it 12 times a year. Quarterly, that would mean that you compound the interest 4 times a year, meaning the interest gets added on to the principal before the next quarter interest would be computed. Annually, it would be once a year. That's what I was using up here. If we were compounding annually, at the end of each year, it would be added on. Biannually or semi-annually would be N equals 2. Then there's continuous compounding, meaning like not only every second, every nanosecond, it's continuously compounding the interest, adding it onto the principal, and getting interest on the interest too. So when it says compounded continuously, we're going to use this formula here. A equals PERT. Some people call it the PERT formula. So you're going to see all this again in Algebra 2 next year for those of you taking Algebra 2. The PERT formula uses this number E, and it's on the calculator. If you look at the top of the keyboard right here, you see that E next to the pi. It's just like pi. It's a constant. If I put it in the calculator right now, you'll see it's that 2.71828 number. We're not going to go into how they got it, but that's the number that you're going to use every time you're compounding interest continuously. And that's when you'll use it next year too. Okay, so this first example, they give us, complete the chart below to determine the balance, A, for $1,000 invested at 3.5% for 10 years and compounded n times per year. So the P is 1,000. The rate is 0.035, the 3.5%, move the decimal 2 places to the left. The time is 10 years, but they keep changing what the n is. So in our formula, the way that you see it, it's A equals P times 1 plus R over N to the NT power. So for the first one, they're saying 1 year. Well, the 1,000s for the P, 1 plus the 0.035 over, I'm going to keep the N open for now, and then there's an N here, and then the T is times 10. So these two numbers depend on the number of times you're compounding a year. Everything else is set up, the principal and the rate and the time. We want to find the new amount. So for the first box, they want us to do it for when it's compounded once per year. So I'll put in the calculator 1,000 times 1 plus 0.035 divided by 1, which I don't even have to put divided by 1, but I'm just going to do it to be consistent. Exponent, again, 1 times 10. I don't have to put the 1, but I'm putting it there to be consistent. And here's what we get. $1,410.598, so 60 cents. So that's how much you would have after 10 years if you compounded just one time a year. Now let's use the formula if it was 2 times a year. So I'm going to change those numbers to 2. And in the calculator, I could go back and take the 0.035 and divide by 2, not 3. And then the exponent, I'm going to add that little 2 times 10 on, enter. And then, oh, that's not 2 times 10. 2 times 10 and enter. And now the interest would be $1,414.778, so 78 cents. So if you're compounding twice a year as opposed to once a year, I mean, it's not a huge difference in money, 1410 to 1414, but it is a significant amount, especially over time. 78. Now, what if it was compounded 4 times a year? So now I'm going to put those numbers as 4 in the denominator and in the exponent. So I could just go and change the 2 to a 4 there, and that 2 to a 4 there, and now it goes up to 1416.91. If it was 12 times a year, now I'm going to change the 4s to a 12. So hopefully this is having you understand what the number that tells you how many times it's compounded annually. So 12 times a year means each month the interest would be added on to the principal before computing the interest for the following month. 365 times a year, so that would be every day they're compounding the interest, adding it on to the principal before finding the interest for the next day. So I put the 365, so the n goes in two places in the formula, the denominator and the exponent, and again, it goes up very little between monthly and daily, pretty much. And then continuously, the formula is going to completely change. That's when we use the A equals PERT, the PERT formula, sometimes they call it. So A would equal the principal, still 1,000, but the base now is that E number. The rate is still 0.035, and the time is still 10 in the exponent. So now I would put next line. 1,000, use the E, that's the number next to the pi key, and then exponent 0.035 times 10. And it's such a slight difference between if you compound it every day and you compound it every second. They say second for continuously, but really it would even be more consistent than that. So it goes from 4 cents to 7 cents in 10 years with this situation. So it's a formula that you just have to understand what all those numbers mean when you plug them in. Let's take a look at the next one. So this is as basic as it could get. You invest $500 in an account that accrues simple interest at 2.5%. How much money will be in your account at the end of 10 years? So if it's simple interest, then you're only getting interest each year on the $500 that you started with. They don't compound it. So I'm going to use interest equals, what was the simple interest? PRT, I thought so. PRT. Okay, that's your simple interest formula. It's right on top. The principal is the $500 that you're starting with. The rate, I'm going to move the decimal 2 places to the left, 0.025, and the time is 10 years. So you're going to get 2.5% of the $500 each year for those 10 years, as opposed to it compounding each year. And then, so you get $125 interest in those 10 years. So how much will be in the account at the end of the 10 years? Well, you still have that $500 you started with plus the $125 interest, and you get $625. So with the compound interest formula, you don't have to add the interest onto the principal. The formula does that for you. It compounds it. It adds the interest on any number of times based on n. The ABC Bank agrees to continuously compound. So this is how you would know which formula to use. Number 2, I underlined simple interest. Here it says continuously compound your investment of $1,500 for 6 years at an annual interest rate of 4.2%. How much money will be in your account after 6 years? So now you're using the A equals PERT, the PERT formula. So your amount would equal the principal, which is the $1,500, that E number. The rate would be 0.042. You guys still struggled with that the second day. 0.042 times the 6 years for time. Put it right in the calculator, 1,500. Use the E button. And then in the exponent, 0.042 times 6. So your new amount would be $1929.89. And there's no adding it. That is how much money that takes the $1,500. It continuously adds the 4.2% interest onto the principal. So that's your final answer. Maybe I'm going to skip 4 for you guys to do on your own. Number 5 is pretty basic. You guys could do that one on your own. And number 6, compounded quarterly. So how many times a year would that mean? That would mean your n is equal to 4. So you guys should be able to do that one on your own. Compounded continuously for number 7. I'll just do this one with you. They're saying as soon as it says compounded continuously, I use that PERT formula. Number 6 would use the other formula with the n being 4. So A equals PE to the RT. The principal's 10,000. The rate is 0.04, 4%. When you move the decimal 2 places to the left is 0.04. And then times 10 for the first case. So 10,000 e to the exponent of 0.04 times 10. You get $14,918.25. If we change the time, all we have to do is change that last number 30 years. It's going to be $33,201.17. And if I change it to 50, I just accidentally got rid of the 0.04 times 50 years. That would give me 73890.56. So $73,890.56. Okay, number 8. Your parents start a college fund for you when you enter kindergarten at age 5. They invest $14,000, so that's your principal. It earns a 4% annual interest, that's your rate, compounded continuously. That tells you which formula you're using. If you are 18 years old when you enter college, how much money is available in your college fund at this time? Well, if you're 18 years old and they invested the money when you were 5 years old, how much time goes by? That tells you that the time would be 13 years. So that was the little trick of this one, why I didn't want to give it to you. PERT formula, because it says continuously. So the amount in the account would be the principal, which is the 14,000, times E to the rate, which is 0.04, times the 13 years that we just discussed. The next input, 14,000 E to the 0.04 times 13, and you're going to get $23,548.39. If it doesn't tell you what to round to with money, you're just going to round to the nearest cent. So that's it. That's how much money you would have when you're ready to go to college. Hopefully that would take care of some of it. Number 9, your financial advisor recommends that you deposit $3,500, so that's your principal, the P, in a fund that earns 3.5% annual interest, that is your R, compounded monthly. So that would be the other interest formula, and N would equal what? If it's compounded monthly, how many times a year is it compounded? 12 times a year. What would be the value of our investment in 4 years? So that's your time, T. So A equals principal times 1 plus R over N to the NT power. So that's the formula up top that you can keep looking at when you're doing your work. So the new amount, that's what they're asking for. They gave you all the other information to plug in. The principal is the 3,500. The rate is, in this case, if I move the decimal 2 places to the left, 0.035. The number of times, the n, number of times it's compounded a year is 12 to the 12 times 4 years power. So I'm going to put 3,500 times 1 plus 0.035 divided by 12 to the 12 times 4 power. And here's your final answer. Always make sure you plugged it in correctly. You didn't type something wrong. And did it say to round to anything? No, so we'll just make it 14 cents because it's 0.138. And that's it. That's how much money you would earn in 4 years. That's how much, that's the value of the investment at the end. Number 10 is a little trickier. Calvin invests $10,000 into an account that earns 3% annual interest compounded monthly. In how many years will the account be worth over $18,000? Round to the nearest hundredth of a year. So this is like the problems that you were expected to do yesterday that you had a little bit of trouble with. They're telling you what they want the new amount about. They're asking how many years. So I'm going to do it the way from yesterday. I'm clearing out the calculator. Okay, so it said compounded monthly again, so I'm going to use that same formula, A equals P times 1 plus R over N to the NT. If it's compounded monthly, the N again is 12. The principal they gave us was $10,000. The rate, 3%, move the decimal 2 places to the left, it's 0.03 over N. How many times? We said 12 to the NT power. The T here is the unknown. That's where the exponent, that's where the variable is in the exponent. The new amount they gave us, but instead of plugging it in there, I plug it in that we want the new amount to be $18,000. Then I'm going to plug the two functions into the calculator. So you have none like this to do on your own today. I would like you guys, if you didn't sit on the phone with me yesterday at the meet, definitely look at the key that's now in the drive so that you understand. So this is what we did yesterday. I'm putting the function in with all the information that was given into the first spot. Okay, I just press enter, it changes it into function notation. Then the constant function, I'm going to put y equals 18,000. Okay, I don't see anything on my screen. I'm going to hit the gear, zoom to fit, and here we go. I tap that point right there, it'll give me how much time it takes for these two functions to meet. So it is 19.617. It's a nearest hundredth of a year. So I'm going to put, instead of 61, the 7's going to give it a shove to 2. 19.62 years it's going to take to be worth over $18,000. The last one I'm not going to make you do. So after looking at these, I want you to be able to do number 4, all 3 parts, 5, and 6. No question marks. If you have a question, contact me on Remind and I will help you.